Okay, yeah, I think we can start. Everyone can hear, right? Is there could we check? Is the voice okay? Or uh okay, cool. Thanks. Okay, thanks, Daro. Okay, yeah. So today there might be more people coming in, but like we can start first. So today we're talking about uncovering ChatGPT, right? So ChatGPT has been like all the craze the past couple of months, since its inception in December 2022. And yeah, today is just a very gentle introduction to the world of LLM, so large language models. And this has been brought to you by NUS FinTech Society, the ML department. Yep. So for today we'll be talking about a few stuff. So this is the agenda. So we'll start off with what is ChatGPT. Then following that, we'll be talking about how ChatGPT works, right? So this is the most technical part of today's presentation. So it'll be a lot of like things like LLMs, transformers, GPT-2, GPT-3. So if you don't understand any of the stuff now, it's okay. Hopefully after today, you'll get a better understanding of how it is. And yeah, number three, we'll be talking about social impact of ChatGPT, so its potential disruptions as well as the value it provides. And lastly, we'll just talk about we'll just provide a demo. So we'll have a conversation with ChatGPT, and you can see how it works. I believe that most of us here in the but I think most of us today here do know things about ChatGPT and have used it before. That's why we are here to further learn about like the technical aspects of ChatGPT. So yeah, so I'll just go through a bit of the terminologies. So yeah, these are just some of the things that I might use later. And like if you feel lost, please like feel free to unmute and yeah, just voice out, or like you can type in the chat. There are some of our lovely people from NUS FinTech who will also reply to you. So yeah, a couple of stuff. So we have GPT, which is generative pre-trained transformers, LLMs, large language models, RNN, recurrent neural networks, as well as LSTM, so long short-term memory network. And yeah, there are just some of the terminologies that I hope that like everyone can kind of like get. But like before moving into the actual ChatGPT, let's talk about the AI timeline, right? So AI has been around since the end of World War II. So around 1947 to today. It has been going through different series of revolutions. So if we see over here, 2011, IBM Watson, which is kind of like an AI system, beats the players on Jeopardy, which is like a talk show. So this is like general knowledge. So it shows that like AI system actually can store knowledge much better than people. Which also makes sense because like it's just a giant database, right? Yeah. And in 2015, kind of like they beat the chess AlphaGo master. So it's something like chess. The AI beat the chess master. So yeah, that's 2015. And then moving on 2017 onwards, we come up with stuff like transformers. And then in kind of 2020, we have the GPT, the entire craze of GPT coming up. Yeah, so this is very brief like architecture of the AI. So AI has not just been around since 2022 when ChatGPT came out, but just want to provide some context that ChatGPT has been around for a long time. I mean, AI has been around for a long time. So yeah, exactly what is ChatGPT, right? So ChatGPT was created with the mission to develop a safe and open AI tools to empower the human race. And it was founded under this organization called OpenAI, which used to be like a non-profit organization when it was founded. It was just a research wing. And it was founded by a couple of people. So notable names, Sam Altman, who is currently still the CEO of OpenAI, as well as Elon Musk, who has left the board since 2018, and a few other notable names. These are kind of like the co-founders of OpenAI, which is like the parent of ChatGPT. So whatever that we see here under like founded, like GPT-3, DALL-E, and ChatGPT, they are all under the OpenAI ecosystem. So OpenAI is like the parent company. So in 2020, GPT-3 was created and introduced to the world. So it's able to kind of produce text that is able to complete a sentence given a prompt. So let's say I am as the prompt, then they'll come out with things like I'm hungry, I'm sleepy, I'm tired, stuff like that. And then in 2021, it came out with something called DALL-E, So this generates images from NLP, natural language description. So I can say I want a guy holding a water bottle and like maybe like a towel. So yeah, it's able to generate like images according to this description, and then like provide kind of like and returns the different images to people to see based on their description. I think that that's like one of the better use cases of AI, where like I don't have to like actively draw something out, but I can just create something with just a couple of words. Yeah. And then in 2022, ChatGPT was created, which is the AI chatbot based on GPT 3.5. Yeah. So GPT 3 was prior, and then we have 3.5, which is after, which created ChatGPT. Yeah. So that's where we are at now, 2023. Nothing new has came out. But just a brief introduction to like the different teams of, the different aspects of the OpenAI system, right? So since founded in 2015, it's been about 8 years since they have been founded, and many people have come and go. So we see some of them in this diagram here today. And yeah, so rest assured that if you're in the AI industry, you can raise a lot of money if you're interested in startups. So these are some of the people who have left OpenAI and have went on to found their own startups. We see that you don't even have to have super in-depth knowledge of like AI. Head of operations, Jeff Arnold, which is like here. This guy managed to raise like 160 million for his kind of like his accounting startup. So yeah, it's impressive that once you're in the AI space, you are able to kind of like get so much value out of it. And yeah, so statistics, right? So some statistics of ChatGPT, we know that ChatGPT, when it came out, it was like the fastest tech product to reach 1 million users. It's managed to reach like this number within 5 days, which is kind of like amazing. Like I believe even like things like Facebook, Netflix, which has such a sticky product, when it first started, there weren't that many people using it. And then by February 2023, which is just last month, it has crossed over 100 million users. So we can just imagine how much of the world population that is. And yeah, the data set has been trained on like 570 GB of data with over 175 billion parameters. So I think that's quite amazing. And for forecast, it has 200 million by 2023. This in USD, which is this year. They are expected to make 200 million revenue, and then 1 billion by 2024. And personally, I think this is very possible, given that they create things like ChatGPT Pro recently. So you get like additional computational space, no lag time, no downtime, and faster responses. And also even like their API, which startups can use to build their own suite of products. So I believe that with such tools, they are definitely able to make this amount of money that they have in mind. So yeah, below are just some geek facts that you might be interested in. So the number of, I think the most interesting one is that it has only about 24 layers, but it's able to create over 175 billion parameters. And also, if you are interested, it's trained on NVIDIA GPUs and was done on Microsoft Azure AI supercomputing technology. So it shows that everything is under the Microsoft ecosystem for ChatGPT and OpenAI. Yeah, so now to the technical part of stuff. So how does ChatGPT work, right? So to answer that, let's understand what is LLM first. So LLMs, like we said previously, is like large language models. So LLMs is a very small subset of machine learning. So I believe some of us here might have heard of machine learning, but not LLMs. So machine learning is the whole thing, the big circle that we see. NLP is like a smaller subsection of machine learning, and LLM is like a small stone in the entire NLP ecosystem. So what exactly it is that it's a large language model is a deep learning neural network that can understand, process, and produce human language by being trained on massive amount of text. So exactly how this training occurs, we can see in the next slide. So over here we have how LLMs are trained. So it starts off with like the top layer, which we see two dark, like the black books as well as the actual output table. So what this is that it's a series of text input, so a series of words with like output. So for example, I am, then like the output might be hungry. That's the correct one. So or like I want to go for, then the actual output is like assume. So stuff like that. So with this data, it's kind of like split into batches. So like the smaller batches, and all this data will be parsed into this brain. So this brain essentially is your model with like a lot of parameters, like W0 all the way to Wn. And it will systematically update the model Yeah, it will systematically update the model every single time, and the model gradually learns the relationship and the patterns of the data. So it kind of slowly improve, and eventually being able to kind of like predict some stuff correctly. But yeah, in essence, LLMs is kind of simple. They are used for basic sequencing techniques to predict words, like next token prediction. So like what I say a suite of words, like a corpus of words, and then I want to predict the last word. Whereas for whereas for okay, so whereas for mass language modeling, it's kind of like creation of like sentence, and then there'll be a word in between. So this is generally like another kind of prediction system. So yeah, LLMs are generally and commonly implemented via LSTM models. So this is a form of recurrent neural network. It's like one of the flavors of recurrent neural network. And this is very popular because I mean, this is the more popular kind of like recurrent neural networks kind of like application, which is LSTMs. Yep. And yeah, so some of the limitations of sequential modeling structure is that the model is unable to value some of the surrounding words more than others. So for example, I have a sentence like John something wants to read. So it's either he likes to read or he hates to read, right? But the model is unable to say like give some weights to John. Like because John is someone who likes to read, the word that they want to predict should be John likes reading. But instead, because they see the word reading, and reading is usually associated to hate, so I hate reading will be predicted. So yeah, this is one of the drawdowns of like LLMs. And secondly, is also that because the data is processed individually and sequentially rather than a whole suite of words, like the whole sentence of words, this means that the LLM generally trained can only reach out to a certain number of words to make their prediction. So if you see this diagram here, it's kind of like it's a box cuts diagram, right? It's only able to reach like the upper limit and the lower limit. Whereas for the other words, it's unable to reach these words to be able to make the prediction. If you want to, it can of course reach your other words, but then it will be much more computationally expensive. So yeah, so this is some of the limitations of large language models, which is why we need some improvements, right? So what are the kind of improvements? So one of the improvements that we see is transformers. So this is also one of the things that ChatGPT was trained on, transformers rather than LLMs. So what are transformers? So transformer is not the transformers that we know from the movies. It's actually something else. So let's explore. And yeah, transformers might be a bit of a hard concept. So at any point of time, please feel free to unmute yourself and ask questions if you have, or type it in the chat and we can respond to them. So yeah, let's move on to transformers, right? So Transformers was introduced in 2017 by a team at Google Brain and has gradually become the model of choice for natural language problems, rather than using RNN like LSTM that we see previously. And what transformer are is basically just a form of neural network architecture, artificial neural network architecture that is able to do stuff like translation, summarization, and text generation. There's a diagram here on the right that I'll go more in depth into later. But yeah, just know that transformer is just another form of neural network modeling. And why are transformers better than RNN, right? So we talk a lot of not nice stuff about RNN. So let's validate it with some like data, some actual data. So number one, transformer has better memory than RNN. So it has the potential to understand the relationships between sequential elements that are far from each other. It has a better attention mechanism as well as allow for parallelism. So this is because, and why RNN cannot do parallelism, whereas like transformers can, is because transformer use kind of like linear, the words are kind of like related linearly in transformers. By RNN, the dependence is kind of non-linear. Yeah, so that's the problem. And why transformers kind of perform better than RNN in general. So these three things. Yeah, but to dive deeper into the exact things of like ChatGPT, one of them is attention mechanism as well as the GPT infrastructure. So yeah, attention mechanism is just some very simple concept. So as the word suggests, attention. So when it's at the word, we look at the diagonal. When it's at the word high and high, we'll get like a score of 98. Whereas like if it's at a word of how and high, the score is 27. So it's able to kind of like focus on a particular word when it has to, which is why we see the diagonal scores are generally higher than the non-diagonal scores. And yeah, that's basically just the attention mechanism. And over here, I would like to show like this diagram how it works via a video. But maybe we can very briefly talk about GPT first. So GPT was released in OpenAI in 2018, but it was first started off as GPT-1, then slowly evolving into GPT-2, GPT-3, and only recently GPT 3.5, which is where we come out with ChatGPT and something called InstructGPT. But yeah, more of that a bit later. So maybe you can spend some time to watch this video, and if you need a break, feel free to do so. Like I'm just going to stream.
Transformers are taking.
Oh yeah, so we have a question. Yeah, why the scores to the word itself are different for different words? Yeah, so this is just a bit based off like the way that the infrastructure is work. Like I don't exactly know like how they calculate the scores. It's probably based off some. Yeah, I get what you mean. Like some certain words. Like I mean, if high and like like high and high versus how and how, right? Why is the score different? So maybe there's certain weightage going on. Like high is a more common word than how. So maybe that's why more attention is given to high. Yeah, or high can be more suggestive of something. So that's why it has a higher score. But yeah, the exact explanation, I can't tell you now, but that's why we have ChatGPT, right? So yeah, let's try to put it into ChatGPT later and see why this is the case. But yeah, if I didn't manage to answer your question, you can always also feel free to just put in ChatGPT. I believe like it will be able to produce a better like answer, a more concrete answer because it has a better database knowledge than myself. So yeah, can just try that out. But yeah, hope I managed to like briefly answer your question. But like yeah, for the very specific explanation, please feel free to stay after to discuss, or like we can put into ChatGPT and get the answer. But yeah, let's just play the video now. So this will explain kind of
layer
like,
can be thought of as
this will explain kind of like the input encoders and decoders for ChatGPT. So this is quite a useful video.
lookup table to grab a learned vector representation of each word. Neural networks learn through numbers, so each word maps to a vector with continuous values to represent that word. Next step is to inject positional information into the embeddings. Because a transformer encoder has no recurrence like recurrent neural networks, we must add information about the positions into the input embeddings. This is done using positional encoding. The authors came up with a clever trick using sine and cosine functions. We won't go into the mathematical details of the positional encodings in this video, but here are the basics. For every odd time step, create a vector using the cosine function. For every even time step, create a vector using the sine function. Then add those vectors to their corresponding embedding vector. This successfully gives the network information on the positions of each vector. The sine and cosine functions were chosen in tandem because they have linear properties the model can easily learn to attend to. Now we have the encoder layer. The encoder layer's job is to map all input sequence into an abstract continuous representation that holds the learned information for that entire sequence. It contains two submodules, multi-headed attention followed by a fully connected network. There are also residual connections around each of the two submodules, followed by a layer normalization. To break this down, let's look at the multi-headed attention module. Multi-headed attention in the encoder applies a specific attention mechanism called self-attention. Self-attention allows the model to associate each individual word in the input to other words in the input. So in our example, it's possible that our model can learn to associate the word you with how and are. It's also possible that the model learns that words structured in this pattern are typically a question, so respond appropriately. To achieve self-attention, we feed the input into three distinct fully connected layers to create the query, key, and value vectors. What are these vectors exactly? I found a good explanation on Stack Exchange stating, the query, key, and value concept comes from the retrieval system. For example, when you type a query to search for some video on YouTube, the search engine will map your query against a set of keys, for example, video title, description, etc., associated with candidate videos in the database, then present you with the best match video. Let's see how this relates to self-attention. The queries and keys undergoes a dot product matrix multiplication to produce a score matrix. The score matrix determines how much focus should a word be put on other words. So each word will have a score that corresponds to other words in the time step. The higher the score, the more the focus. This is how queries are mapped to keys. Then the scores get scaled down by getting divided by the square root of the dimension of the queries and the keys. This is to allow for more stable gradients, as multiplying values can have exploding effects. Next, you take the softmax of the scaled score to get the attention weights, which gives you probability values between 0 and 1. By doing the softmax, the higher scores get heightened and the lower scores are depressed. This allows the model to be more confident on which words to attend to. Then you take the attention weights and multiply it by your value vector to get an output vector. The higher softmax scores will keep the value of the words the model learned is more important. The lower scores will drown out the irrelevant words. You feed the output vector into a linear layer to process. To make this a multi-headed attention computation, you need to split the query key and value into n vectors before applying self-attention. The split vectors then goes through the same self-attention process individually. Each self-attention process is called a head. Each head produces an output vector that gets concatenated into a single vector before going through the final linear layer. In theory, each head would learn something different, therefore giving the encoder model more representation power. Okay, so that's multi-headed attention. To sum it up, multi-headed attention is a module in a transformer network that computes the attention weights for the input and produces an output vector with encoded information on how each word should attend to all other words in a sequence. Next step, the multi-headed attention output vector is added to the original input. This is called a residual connection. The output of the residual connection goes through a layer normalization. The normalized residual output gets fed into a pointwise feed-forward network for further processing. The pointwise feed-forward network are a couple of linear layers with a ReLU activation in between. The output of that is again added to the input of the pointwise feed-forward network and further normalized. The residual connections helps the network train by allowing gradients to flow through the networks directly. The layer normalizations are used to stabilize the network, which results in substantially reducing the training time necessary, and the pointwise feed-forward layer are used to further process the attention output, potentially giving it a richer representation. And that wraps up the encoder layer. All of these operations is for the purpose of encoding the input to a continuous representation with attention information. This will help the decoder focus on the appropriate words in the input during the decoding process. You can stack the encoder n times to further encode the information, where each layer has the opportunity to learn different attention representations, therefore potentially boosting the predictive power of the transformer network. Now we move on to the decoder. The decoder's job is to generate text sequences. The decoder has similar sublayers as the encoder. It has two multi-headed attention layers, a pointwise feed-forward layer, with residual connections and layer normalization after each sublayer. These sublayers behave similarly to layers in the encoder, but each multi-headed attention layer has a different job. It's capped off with a linear layer that acts like a classifier and a softmax to get the word probabilities. The decoder is auto-regressive. It takes in the list of previous outputs as inputs, as well as the encoder outputs that contains the attention information from the input. The decoder stops decoding when it generates an N token as an output. Let's walk through the decoding steps. The input goes through an embedding layer and a positional encoding layer to get positional embeddings. The positional embeddings gets fed into the first multi-headed attention layer, which computes the attention score for the decoder's input. This multi-headed attention layer operates slightly different. Since the decoder is auto-regressive and generates the sequence word by word, you need to prevent it from conditioning to future tokens. For example, when computing attention scores on the word am, you should not have access to the word fine, because that word is a future word that was generated after. The word am should only have access to itself and the words before it. This is true for all other words where they can only attend to previous words. We need a method to prevent computing attention scores for future words. This method is called masking. To prevent the decoder from looking at future tokens, you apply a look-ahead mask. The mask is added before calculating the softmax and after scaling the scores. Let's take a look at how this works. The mask is a matrix that's the same size as the attention scores filled with values of zeros and negative infinities. When you add the mask to the scaled attention scores, you get a matrix of scores with the top right triangle filled with negative infinities. The reason for this is once you take the softmax of the mask scores, the negative infinities get zeroed out, leaving a zero attention score for future tokens. As you can see, the attention scores for am have values for itself and all other words before it, but 0 for the word fine. This essentially tells the model to put no focus on those words. This masking is the only difference on how the attention scores are calculated in the first multi-headed attention layer. This layer still has multiple heads that the masks are being applied to before getting concatenated and fed through a linear layer for further processing. The output of the first multi-headed attention is a mask output vector with information on how the model should attend on the decoder's inputs. Now on to the second multi-headed attention layer. For this layer, the encoder's output are the queries and the keys, and the first multi-headed attention layer outputs are the values. This process matches the encoder's input to the decoder's input, allowing the decoder to decide which encoder input is relevant to put focus on. The output of the second multi-headed attention goes through a pointwise feed-forward layer for further processing. The output of the final pointwise feed-forward layer goes through a final linear layer that acts as a classifier. The classifier is as big as the number of classes you have. For example, if you have 10,000 classes for 10,000 words, the output of that classifier will be of size 10,000. The output of the classifier then gets fed into a softmax layer. The softmax layer produces probability scores between 0 and 1 for each class. We take the index of the highest probability score, and that equals our predicted word. The decoder then takes the output and adds it to the list of decoder inputs, and continue decoding again until the end token is predicted. For our case, the highest probability prediction is the final class, which is assigned to the end token. This is how the decoder generates the output. The decoder can be stacked n layers high, each layer taking in inputs from the encoder and the layers before it. By stacking the layers, the model can learn to extract and focus on different combinations of attention from its attention heads, potentially boosting its predictive power. And that's it. That's the mechanics of the transformers. Transformers leverage the power of the attention mechanism to make better predictions. Recurrent neural networks try to achieve similar things, but because they suffer from short-term memory, transformers are usually better, especially if you want to encode or generate longer sequences. Because of the transformer architecture, the natural language processing industry can now achieve unprecedented results. If you found
Yep. So okay, yeah. That's about it. I hope that this video kind of provide a more technical understanding of like how the kind of like the attention networks as well as stuff like the things that you guys may be interested in, kind of like how it works. But I'll drop the link there so you guys can always reference the video. Yeah, but yeah, I'll just move on now. Hope you guys enjoyed the video and had a ability to kind of like take a short break. But yeah, so just now we were talking about the different GPTs, right? So yeah, so they recently with ChatGPT, they come up with Instruct GPT and ChatGPT. So what's Instruct, right? Most of us are familiar with ChatGPT, but not Instruct GPT. So Instruct GPT is basically, as the name suggests, I mean not as the name suggests, but like as the website suggests, a less toxic and more truthful GPT-3 model. So basically, it's something that is able to give less of a how do I phrase it? But like the answers are generally less like fake, less fluff. Like they only answer things that they know, and like if they don't know, they kind of will like not give you a false answer. Whereas with ChatGPT, it'll kind of like use some inference to kind of give you an answer, a fact that might not even be true. So yeah, Instruct GPT is generally, if you want a more wholesome kind of like language model, then you use Instruct GPT. But of course, it's less powerful than ChatGPT because it's trained on less number of data, less number of parameters and stuff like that. But yeah, just in case like anyone is interested in Instruct GPT, you can always check it out. So yeah, moving on, the next step is to understand the GPT evolution, right? So we have GPT-2 and GPT-3, and most recently GPT 3.5. But we see that the number of parameters from one GPT kind of like cycle to another is almost 100 times. So we see 1.5 billion parameters for GPT-2, but when it went to GPT-3, it's kind of like 100 times, so 176 billion. And the amount of data that has been trained on, we see that GPT-2 had like 40 GB, but when we went on to GPT-3, it's almost like 500 GB. Yeah, and then things to look out for this kind of like this year is that GPT-4 is being expected to release. It's due for a release in 2023, which is this year. And yeah, it's not going to have 100 trillion parameters like some people speculated. So yeah, don't get your hopes up too high, but I think there's definitely 4 will be much more powerful than GPT-3. But yeah, just don't get your hopes too high that you can solve all the issues with GPT-3. Yeah. So now moving on to like the steps, right? So I believe these parts will be a bit more technical as well. This is very interesting because like next time if you go out, you can kind of like explain to your friends like how ChatGPT is being trained. So it's honestly a lot of stuff, but I'll strip down into like 3 steps. So number 1 is supervised fine-tuning model, so SFT model. Step 2 is reward model. Step 3 is reinforcement. And yeah, that's basically it. And we'll look a bit of how to evaluate the model later on. But yeah, okay, let's start off with step 1, right? So supervised fine-tuning model. So the way to look at this slide is that we'll go from the top right to the bottom. So on the top right, we see that on the top right, we see that supervised fine-tuning model is basically essentially creating supervised training data set to fit into GPT-3 model, because we went on from GPT-3 to GPT-3.5, right? So that process involved creating a supervised training data set to improve the GPT-3 model. So how this is done is that we'll collect prompts, which are inputs into the model, and then there'll be labelers to kind of create the appropriate response. So like the output. So for every given input, there's a correct response. So the labelers will go, and labelers are basically people hired, like legit human beings are hired to kind of like label the data set. So for every text, there'll be kind of like a certain output, right? A certain response. Yeah, so that's where the labelers come in. And yeah, the input prompts are generally the things that the places where they get the data. So number one is of course actual user entries. So we have GPT-3 model. So with this GPT-3 model, these are kind of like inputs into the OpenAI API, and this will be fed into the model. Then there are other stuff like plain prompts, few short prompts, user-based prompts. These are kind of like things that the labelers, who are human beings hired, kind of like create specifically for certain kind of use cases. So very specific requests and words being used, you need to create such an infrastructure to be able to account for them in the model. So this is where these three other steps come in. And yeah, but most of the data is generally from actual user entry, so actual questions that users have asked, and what are the specific answers that they kind of want to obtain, the labelers will kind of label it. And the group of responses for generation, so like the output, like I previously mentioned, is basically there's a few. They are just direct few shot continuation. Like don't really have to understand like what it is, but like just know that there are like these three kind of like output that can be generated. And these are how they are being classified when inputting into a model. So the model is built with intention of these three items. Yep. Yeah, so there were over 13,000 input created, so you can imagine 13 different situations, sentence situation corresponding output. And yeah, this data was used to fine-tune the GPT-3 model when building the GPT 3.5 model. And yeah, on the left is just basically some summary of how this entire thing worked. So we see that 40 contractors were hired to write responses to prompts. So it's a very manual work. And we create like input-output pairs to train the supervised model known as GPT-3 to create GPT 3.5. Yep. But second step, so the reward model. So this is exactly as the name suggests. So the model basically produce output to maximize the rewards. So I believe some of us here who have taken like maybe like the AI mods in NUS would kind of know about like reward-based system very well. But this is basically trained via reinforcement learning. So the labelers are given 4 to 9 outputs from the SFT model created in step 1. Then they'll uniquely rank the output. So maybe like out of 9, which output is most suitable for a certain input. So let's say I am, then there's a word, I am laptop. So maybe like there's not a really good like output, so it'll be like ranked the last. Whereas I am hungry, that is a good output, so that will be ranked first. So by creating this ranking system, we'll know like which word is kind of like the best or to be used. But when they did it gave rise to a problem called overfitting. So they kind of like fine-tune the model too well to specific use case, such that on like things that the model had never seen before, it's unable to produce kind of inference for it. So to deal with this, we use group ranking as a single batch data point. So basically ranking a group of inputs and output pairs together rather than taking a single input-output pair when doing scoring. So the summary of that is on the right. So if K is the number of printed responses, there will always be K choose to individual rankings that will occur. So from there, you can choose like specific pairings to use. Yeah, but that's basically the reward system. So with a reward system, we can finally move on to the last part, which is the reinforcement learning. So reinforcement learning, in essence, is having a prompt going into the model. So on the left, you see there's a prompt going into the model, and then we create a response. And then these are our labelers on the right. They will create, they'll determine whether it's good or bad, and then they'll feed it back into a model. So this is a continuous process that constantly occur. And yeah, that is why it's called reinforcement learning, because you get the data, you feed it back into kind of like the model and kind of iteratively train it. And yeah, the process to do so, there's a terminology alert because like it's kind of like steep, right? I mean, like the words are kind of like hard. So okay, let's go through it slowly. So proximal policy optimization was introduced for this process of iterative training. So this is basically the methodology used to update the model's policy as each response is generated. Yep. So specifically, it's using the Kubeck label penalty. Okay, I'm just showing names and terminologies out here, but basically what you need to know is that how this back arrows happens back to the model from the prediction to the model is that you use similarity scores and penalizes those with extreme distances. So those outputs that are very far away from the actual output. So the predicted is very different from the actual item. And yeah, it just reduces the distance the response can be according to the SFT model, and then retrain the model. Re-input to the model and train it again. So yeah, it's basically simple reinforcement learning. Input, model, output, determine the scores, put it back into the model and try again. So this will happen a few times before we get a final model. Yeah, so this is a summary of reinforcement learning. But in essence, if you don't take away much from this section, just know that reinforcement learning is this blue arrow here. It learns something, it feeds it back into the model. Yeah, basically. So steps 2 and 3 are repeated iteratively, and this can happen for a number of times until like a certain score or like a certain number of times it exhausts all the number of iterations, and then we'll stop there. Yeah. But how to evaluate the model, right? After building the model, we need to understand a few ways to like see whether this model is good or bad. That's where we have 3 metrics in general. One is helpfulness. So the model's ability to infer and follow a specific user instruction. For this, Instruct GPT generally performs better than GPT-3, as we discussed previously, right? As for truthfulness, the model tendency for hallucination. So basically, it's just whether the model will kind of like give a lot of nonsensical responses. So this is done by using a truthful QA dataset, which is a benchmark for modeling, as well to understand whether output is false or not false, or like nonsense or not. Then harmlessness. So I think when ChatGPT was first released, it was quite harmful. They were able to predict things like how to make like explosive and stuff like that. So that's pretty dangerous. So which is why after that, after fine-tuning the model, they kind of like remove this capability, because these are stuff that although it's general information, it shouldn't be let to the public easily. Yeah, so these are kind of like how we evaluate whether a language model is doing well. But yeah, so I'm kind of done with the technical aspects, which is so now we are moving on to part 3, which is like the social impact. So these are kind of like the fun stuff, the business side of things, as well as like the things that is popular. So yeah, let's just go through this very quickly. So yeah, ChatGPT, the positive social impacts of ChatGPT for schools, right? For students is that they are able to access information quickly. I believe like these are some of the things that even we as university students will have experienced, like putting certain question prompts into like the GPT model and trying to get an output to like be able to understand certain things easily. Like for me personally, I use it for coding questions to like understand what is the instructor trying to like test. Like, is it a specific like skill set or whatever? GPT is able to tell you that. Of course, if you ask for the answer, then that's kind of cheating. So yeah, so just use it correctly, and yeah, you're able to benefit for it, right? Yeah, as for teachers, they are able to create customized learning experience because they are able to get better suggestions, more creativity. They are able to create educational resources much easily, right? Because they don't have to spend like 5 hours thinking of lesson prep. Whereas if they put it into the ChatGPT, they are able to get prompts, and then they are able to create kind of like lesson structures, lesson informations much quicker. But yeah, so we see that the positive impacts are much less than the negative social impacts, right? So yeah, for students, it's kind of bad because it kind of hinder the need for critical thinking, right? When you have a thinking mechanism here for you, because AI is basically something that you want it to be able to think for you, to do stuff for you, to replicate the human brain. But yeah, if you keep using AI to do all your tasks, automate all your tasks, you'll realize that you lack the ability to think in the future. So you might do well for assignments, but you might not do well for exams because you're unable to think of like the thought process that the examiner is trying to kind of like test you. Yeah, and there's a lot of things like threat of plagiarism, Like I believe like in NUS we have like things like signing a waiver where saying that we are not allowed to use like GPT materials or AI learning tools. Yep. For teachers, of course, it's job loss because like why do we need a tuition teachers, right, when we have ChatGPT to ask? But then again, there's always two sides to the coin. Using ChatGPT is good for basic stuff, but when you really want to understand some things, ChatGPT might not be as good as a human who has domain knowledge, who has been in like the teaching industry for very long, knows exactly what kind of examination styles the kind of like that will come out for your national exams and stuff like that. So yeah, and cheating, like we see many universities banning ChatGPT and stuff because they don't want people to like utilize this tool. Personally, I think that both it's collective effort from both sides. So universities should kind of like be able to embrace this and create more questions that test students' ability to be able to formulate things rather than like hard code stuff. Because though ChatGPT is kind of like a AI software where it can do some kind of thinking for us, generally it's much better in mundane tasks, like writing like codes to test like maybe like writing a recursion code. It's very good at those kind of stuff. But like doing critical thinking, these are stuff that might not be tested due to the lack of time. But now with kind of like AI in place, schools can adapt, and I think they have been adapting. We see all our questions that are coming out for our assignments that are not being able to solve using ChatGPT, and that's intentional. They want us to be able to create an ecosystem whereby we learn more than we try to like memorize things and regurgitate during the examinations. Yeah, and yeah, GPT-0, so which is the negator for kind of like ChatGPT, right? This is to detect whether someone use AI for their work. But honestly, the real way to kind of like go around this is that GPT, I mean like AI written text is tend to be uniform, whereas like in human we have emotions, we put in different stuff. So the sentence structure and everything will be very different. And whereas AI written text, there's some kind of like distribution to it and like it's uniform. So like if you really create something like an essay via ChatGPT, the advice is just to like change your sentence structure lah. Like take the points, change your sentence structure, then you won't get flagged out. And yeah, I think that's a good way of using ChatGPT to like kind of like get the pointers, but then you rephrase the stuff that you have. Ethics wise, ChatGPT definitely has its shortcoming. It will overtrain towards its bias. It's sometimes factually incorrect, which is why we have Instruct GPT, which is most of the time correct. ChatGPT will kind of like make up nonsense. So yeah, when you use it, just beware. Not everything is true. And the output can be sexist or racist. So that's because they don't have the human emotions. So that's the aspect of it that AI has to improve on and probably will as it becomes more and more human-like. And yeah, we next go through like the value chain of ChatGPT. So this is basically what we got out from after hearing like Simon Altman talk, like via various conferences. So number one is that ChatGPT has their own API, right? So people can do domain focused usage by training the base model on a particular domain. Because ChatGPT basically is a large language, I mean it's like a language model, a very huge one, and it's able to perform a lot of tasks, but not well. But if you are able to fine tune it with further data, you can get specific domain. So maybe, for example, marketing domain in retail sectors, or maybe like finance sectors for, I'm not sure, kind of like understanding trends in stock markets. These are stuff that you can use AI's help to do, but you need to further train it. And this can be packaged as a service, like software as a service to sell to other people. So this value chain that's created will give rise to a lot of startups in the future, which is what is envisioned of the entire infrastructure of AI. Yep. And his outlook on Sam's outlook, which is the founder, outlooks on the AI industry is that in the future we have small models where everyone can train, small language models. And this can be used in education or simple use cases in business, like maybe like a simple forecast. But then there will be stuff like large models, which can only be trained by companies like Google and Microsoft. And there'll also be like base models, which is provided by GPT, which like they train a large model and they make it available to like everyone. And this give rise to specific models for a specific domain. And then, like we said previously in the first part, this will create a lot of use cases for startups as well as services to be created. And yeah, we can definitely see a lot of kind of business models that come out around AI in the coming future that are more legitimate than what they are now. Now it's just a lot of hype and like a lot of people just throwing buzzwords out there. But like in the future, we'll really see like the power of AI. Like, yeah, so let's just say I want to be able to learn Fibonacci sequence well, right? So I put in ChatGPT, I get something. This is a while loop that we see here. So, okay, so basically, if you are not familiar with programming, I apologize. There'll be another example where it's less coding related. So yeah, but in this case, it's for more computing people to understand. Like, I mean, people who do a bit of coding to understand this. So see that we put in Fibonacci sequence, we use a while loop, so it's an iteration, right? So let's say I understand the iterative method. Now I want the recursive method because I think that recursion is a more important concept to me than iteration. So I put it in. So I asked them to write the same code, the same Fibonacci code, but in recursion. So ChatGPT will then provide you the code for Fibonacci but in recursion. And this is powerful because you don't have to say, write me the Fibonacci sequence in recursion. You can just, it's able to understand and infer that you meant Fibonacci sequence, the code for Fibonacci sequence, but in recursion. Yep. So we see here that we get a recursive code because it calls like, yeah, it basically calls sequence. I think, yeah, it calls Fibonacci sequence here. Sorry, my bad. Yeah. So over here, it calls this code. So that's why it's a recursive one. And then lastly, let's ask for the time complexity. So now we don't have to say time complexity for the algorithm for Fibonacci for iterative and recursion. We can just say both algos. ChatGPT is able to infer that you are referring to the previous two algos and able to come out with like kind of like the time complexity for both of them. So I find that this is one of the better ways to use ChatGPT, which is kind of like for understanding purposes. And when doing so, kind of like use it iteratively. Don't type in your entire coding question inside or your entire like programming question inside. More like start off with a little bit, let ChatGPT learn, and then it's able to suit your needs better. It's a two-way process. If you just throw in something that is like very complex, ChatGPT might throw out nonsense. Like because we learned that ChatGPT, when they can't answer, they just fluff. So rather we do something like this, we are able to slowly get out like the outputs that you want, let it learn. So this is actually also a learning process for them, and it's able to kind of like get the output that you want. So we see that the different time complexities for iterative as well as recursive method. Yep. So this is very good for learning algorithms. So I believe like if we are all from computing and do things like technical tests, then this might be very helpful in terms of like preparing for your tech interviews. Yep. Okay. So next, number 2. Let's say I want to do a FYP. So this might be everyone's problem in within the next 4 years. So we want to create a question, right? Let's just say your FYP is open-ended. So you put it into ChatGPT, you ask for kind of like inputs for time series analysis, because let's just say you are doing a time series. Okay, it's not really open-ended. It's open-ended, but you can do anything in time series, right? Your professor say, okay, do a topic on time series. So you ask ChatGPT to give you some project ideas that you can pitch to your professors, some FYP ideas. So we see that it'll come up with like generally a suite of like different time series analysis that you can do. So yeah, this is relevant to everyone. It might not be time series, but it might be like something else, right? Maybe in like medicine or in pharmaceutical stuff. But like in essence, it's basically like predicting it's basically like writing you prompts to help you choose or give you a suite of options for your FYP projects. Yeah, so it's a lot of words. So you can give it some read. You can ask for, usually at this point, what I'll do is I'll ask, like, let's say I'm very interested in like a specific point 1, forecasting stock prices for time series analysis. Then I'll ask it for more information. So you don't even have to say like, so let me just copy this code. You don't even have to say like you want the time series for forecasting stock prices. You can just say, I like the first idea or like the second idea. Tell me where tell me more about it, or in this case, I want to know where to source the data for forecasting stock prices, right? So then ChatGPT will be able to tell me, oh, there's Yahoo Finance, or there's Alpha Vantage, or like maybe like Capital IQ, or so on and so forth. And yeah, this is really good because you're able to tell, you're able to get a lot of information from like different sources. And yeah, you don't have to like Google it. You can just put in ChatGPT and iteratively you understand what you're saying. And yeah, lastly, let's just say you decided that you want to do this. This is topic that you love, and then you just ask for a summarization of points. Don't ask for the actual essay. Like I said, it's very easy to be caught for like plagiarism, or like there's counter tools to it. But rather use it to create a point structure, like some of the different points that you have, and then like kind of put right in your own words like each point. So for example, introduction, the data source, EDA, time series analysis, and evaluation model. So these are stuff that you shouldn't ask ChatGPT to do for you. You can ask for explanation, ask for help, but in general, you should use it in this way, like use ChatGPT in this way, iteratively get what you want in a very general level. Like our next later talk about some of the limitations that GPT has. I think some of you like posted the questions. So yeah, like there are certain limitations to ChatGPT in this aspect of like kind of like being able to create certain prompts for you. Yeah, but if anyone is interested, there's a more in-depth ChatGPT research done by an NUS PhD student that was shared. So you can scan the QR code. It's a YouTube video. I believe it's like over an hour, but it basically covers a lot of different ChatGPT stuff, but it's on a very technical level. So if today's session has not been technical enough, yeah, please view this recording, and I think you'll be impressed. Yep. Okay. Yeah. So okay, I'll put there for like another like 10 seconds. Okay, but yeah, we can open questions in a bit. Like I just wanted to answer some of the pre-questions that were asked during during like the fill up form. So there are some people asking the disadvantages and drawbacks of ChatGPT, right? And the tasks that they can't complete, like which I'll briefly go through. The second question is that has how can the common man utilize ChatGPT for investing? Yeah, this is an interesting topic, and we are also kind of exploring it in NUS FinTech Society. But yeah, let's see. So in the first question, the drawbacks of ChatGPT, right? So this list can go on for like 100 pages, but like just to take up a few that I've found out, they are great at what they have been trained on. So like past data, because they have biases, right? So there are some stuff that they'll be better on. But for similar things, it can do a bit of inference and give you average response. But things that it has never encountered before, then it might be a bit hard. Like there's stuff that may be very specific to you as a human being, then it might not be able to kind of like, because it hasn't been trained on, it might not be able to infer kind of like the necessary information to be able to give you a concrete response. Yeah, and it can't do any prediction for anything in the future. So like to link it a bit to the second question, like investing and endeavors, right? You are unable to kind of like predict, say, which stock should I buy? It's unable to do such stuff, even though it's been like, I mean, even though it has so much knowledge, right? I I don't think it's unable, but it's more like it's unwilling. Like the founders probably like curb this functionality because like if they are able to forecast everything, and they might get into some serious issues, legal issues. So yeah, and it can't do anything that involves looking up the web. So you can only do stuff that it can only do stuff that it has already known in its database, and it can only take in text and not images. And I find this the particular pain point for me. Like I'm not able to put in images sometimes to kind of like explain. For example, if you have a graph theory, how do you explain graph in kind of like text, right? Kind of impossible. Yeah. So these are some of the drawbacks. Unreliability is that it's bad at coding. Now I've tried it before. I believe all of us here might have tried it before. The coding prompts are good to give you a general structure, like a skeleton, but it's never good at coding specific tasks. Like you can't build a website with ChatGPT alone, yeah, without any programming knowledge. Yeah, and it's prone to fabricating answers if its knowledge doesn't cover, right? So this is why we have instruct GPT instead of ChatGPT, like we mentioned. Yeah. As for the second question that was asked, it can't give you specific investment advice. So like I asked for what should I buy in the stock market, so they'll say they're unable to give specific investment advice, so on and so forth. Yeah, I think this functionality is curbed so that it doesn't get into any legal issues, and also it's not that easy to do this stuff, right? Usually even advice comes from trading. So if you really want a model, machine learning model, then definitely should check out quant stuff, like quantitative trading or stuff like that, to kind of like understand about more about like investments and trading, rather than kind of like learn about those kind of forecasting models for stock price prediction maybe. And yeah, what you can do is to ask for knowledge for investing. So like provide some good investment practices or like some good quant strategies to learn. So don't be lazy. Always ask for things where you can implement yourself. And this is how ChatGPT can help. Yeah. So they'll tell you like some of the good quant strategies to use to maybe trade. So yeah, definitely check it out. And yeah, with that, we kind of end our presentation here. So this is the team. It consists of me on the left, Sean in the middle, who is currently an NOC, and Usman. Yeah, but that's basically the team. And I thank you for your time. Feel free to scan the QR codes. They are linked to our LinkedIn. But yeah, with that, you can feel free to unmute yourself or type in the chat if you have any other questions. We'll be happy to answer all of you. Yep. Yeah, but thank you, guys, for attending today's session. I hope it's been insightful. If you want something more, oh, sorry. Yeah. If you want something more in-depth technical, refer to like the QR code that I was shown previously. But this is just very briefly like how neural networks. I mean how ChatGPT works. Yeah. Thank you very much, Daru. Yep. Feel free to unmute or like type in chat if you guys got any questions.